Hello everyone. In this video, we are going to see closures in JavaScript, one of the most asked interview question. By definition wise, closure is a function that is bundled together with its surrounding state of the lexical environment or lexical scope is called closure. So to understand in depth, we'll understand how JavaScript code is executed. When we try to execute any JavaScript code, it will create something called call stack, in which the JavaScript execution will happen. Inside the call stack, at first, it will create something called global context, in which the variable declaration or function declaration will happen. In between, if it find any function call in our script, that will have its own scope created. For example, in our script file, if we have something called function parent and it is getting called, then it will create its own scope. Maybe we'll name it as parent scope, or maybe parent function scope. That will create its own function scope and it will have its execution inside it. But within this parent function scope, it will have access to its lexical scope. So what is the parent function's lexical scope? The global context. So within this parent function, we'll have access to this global, whatever the variable declared inside this global object, will still have access. Now we'll consider inside this parent function, we are calling another function called child. Now this child function, again it will have its own functional scope and it will have its own execution inside its functional scope. But this child functions for scope will still have access to its lexical scope. So what are all the lexical scope of this child function now? The parent as well as global. So now this function child function scope will have access to both parent function variable as well as global context variable. Once the execution of child function is completed, that will be removed from call stack, and after parent function execution is completed, that will be removed from call stack. And if there is nothing to execute in our script, the global context is also removed from call stack. So this is how any normal function execution works in JavaScript call stack. Now we'll try to understand with respect to closure. With respect to closure, similarly, it will have global context created. Again, the variable declaration and function declaration will happen inside that. And if it find a function called parent, and uh, again, it will create its own scope. Parent function scope it will be created, and it will have execution of this parent function logic inside that its own scope. But it will still have access to its lexical scope, that is global scope. But now instead of calling this child function inside this parent function, we are just returning the definition of this child function as a output from parent function. So we are not calling this child function inside parent function. Instead of that, we are just returning this child function as an output. So now this parent function will have access to this global context, and it will just return this child function. It is not executing, so there is no more function to execute. Now the parent function execution is completed, then it will be removed from call stack. After that, we have a code to execute whatever returned from parent function. So what is returned from parent function? The definition of child function is returned from parent function. So if we call that output, which is child function, in our global context, then this is again a function, right? So it will create its own functional scope. Within this child function scope, it will still have access to its parent scope. So this is what a closure. Now you can see the parent function execution is completed. That is completely removed from call stack itself. But even if we call this child function, after it a parent scope is removed from call stack, it is still having access to its parent scope. So this is what we'll call it as a closure. A closure is nothing but a function that is bundled together with its surrounding lexical scope state, even after the parent scope is removed from call stack. So this is what we'll call it as a closure. So once after the child execution is completed, that will be removed from call stack, and if there is nothing to execute in our script, the global object also will be removed. Now we'll move to code part to understand closure in detail. So for this demo purpose, I have created an HTML which is just having one title closure demo, and it is having this script reference main.js. This main.js is just a plain file. If you go to browser, it will just have this page HTML pages running. That's it. Now we'll move to our script and we'll try to implement the same what we have seen in our presentation. So this is our global context, what we call when we execute this JavaScript file. So this whatever we are the script, complete script outside, right? That is what a global context. Inside that global context, I'm having one function declaration called parent. So this is a function declaration. Inside that, I'm going to have one variable called a equal to 10. Okay, maybe before that I'll do. So maybe I will have something called a in our global object, meaning global context. Then I will have something called b in our parent object. Okay. So to prove that this parent function will have access to its lexical, which is global context. So now I'm going to do console log. Maybe I will say inside a parent, what is the value of a, what is the value of b. So the a is coming from its lexical scope, which is global context, and b is coming from its own functional scope. The function declaration is there. Then we have some line to call this function. Okay. So when the JavaScript call stack is created, first it will create a global context where this declaration and all will happen. The moment it find this parent function call, it will have its own function scope created. This parent function will have its own function scopes created. Inside that, it will have this variable declaration, and this function scope, this parent function scope, will have access to its lexical scope, nothing but a global context. So inside this parent function, we should have access to this variable a, which is in our global context. Now we'll see what are we getting. If you see, we already got output like inside a parent 10 and 20. So variable both a and b are accessible inside this parent function. Okay. Now the other case is if we have a function inside a parent function called child. We have a function inside the parent function called child, and it is having another variable called c. Okay, we'll maybe put 30. Okay, now we'll put the same inside this, inside child. Maybe I will put a, b, and c. We'll put c. So now we just have another function declaration inside this parent function. So until it is getting called, it's just a declaration, nothing will happen, right? So we are going to call this function. Okay, we're going to call this function inside parent function itself. Okay, so first it will create this parent function scope, and it will execute line by line. The moment it reach this line, so it will find the child function should be called. So it's child function declaration already happened. Then it will call this. So when it executing this child function, this again will create its own function scope. Inside this child function scope, it will have access to its lexical scope. Like it will have access to its parent function scope and the global context. Both it will have access. So we should able to get the value from C from its own function scope. We should able to access a value B, which is from its immediate parent, and a value A, which is from it is global context. So all those should be accessible inside this child function. Okay. You can see inside child we have access to all. To understand a bit more, we'll go to here and I'll just put a console log. Yeah, when we are inside this child function, what are all the scopes available? You can see the c, which is immediate function, immediate variable. In this own function scope, the c variable is available, so it is in local scope, and it is having something called closure here. So that is named as parent. So it is having closure called parent, nothing but a parent function, so inside which this function is running, right? So this is creating closure for it is immediate parent, and it is holding this b. See, in parent closure, only b is there because this only b variable declared in inside parent function scope, right? Again, there is something called global. So inside which we have variable a, correct? So inside the global we have a, and inside the parent scope we have b, and inside the child scope we have c. So this child function is having access to all these three scopes. You can see this b is nothing but a closure. Okay, so this is what we need to understand from JavaScript execution. Now it will have access to all these three. Okay, yeah, the child function is having access. Now the next case is, instead of calling this function inside this parent function itself, now maybe if you see, when we call this child function, the when we call this child function, still parent function is alive, it is not completed its execution, correct? If you have if you have some line after this function call, that will still has to execute, right? The parent function call is not completed, meaning the parent function scope is not removed from call stack, that is still there. You can see that is why we are still seeing closure b parent, right, in outside itself. Now what we'll do, instead of calling this child function inside parent function itself, to get the parent function removed from call stack, I'm going to just return this function definition from this, so that once it return this child function definition, the job of parent function is done, right? So that should be removed from call stack. So now we'll call this, but this function will return child, correct? Let child, I will name it as child func equal to this. Okay, now what output of this parent function call will be a child function. Okay, so what we are going to do, we are going to call this after, outside of this parent function. Now when it reaches this line, by that time the parent function job is done, that should be removed from call stack, correct? We'll see what is happening. To understand this, we'll put a breakpoint after this parent function call completed, maybe here. So by this line, the parent function call is completed. The parent function should be completely removed from call stack, correct? So I'll have one breakpoint in here, okay, when it is inside execution of parent function, and after the completion of parent function execution, we'll see. I'll just refresh. Okay, now it is inside parent function. You should see there is a scope b, this is the local, because right now it is inside the execution of parent, so the local scope is nothing but the parent function scope that is having b variable. Okay, now I have a breakpoint outside. Now if you see, after the parent function execution is completed, in the scope you can see nothing is there, only global scope and the function declaration, whatever script scope is there, correct? The function scope, meaning the global scope and script scope, only two are there. So we'll see what is there inside script scope. It is having this definition of child function, so what that is what returned, right? So inside that it will have something called scope. You can see this is having something called closure. So this is having all the scope what it is having access. So this child function, what it is returned from parent function, having access to all these three scope. One is closure. This closure is nothing but its parent scope. Okay, you can see the name of the closure itself is parent, and it is having access to b inside it. And another one is script scope. Script scope is nothing but its own scope. Okay, and another one is global scope. All these three it is having access. Now we'll see. Okay, nothing is, it is there in script scope, not it moved to call stack yet, right? So this is somewhere kept for storage. Now you can see nothing is there in call stack. See, the call stack is empty. Now okay, it's not empty actually, the global context will be there, because we have something still to execute. I will continue it. Now we are inside this child function. By this time the parent function is removed from call stack. Now we'll see what is there in call stack. You can see now the current scope is this function scope. So the c variable c is there, it is not assigned. If I move to next, the variable c is getting assigned. The local scope is child function scope, in which we have c and its closure parent. So the parent scope is already removed from call stack, but when we execute a function that is returned from parent function, it is having access to its parent scope b, and it is also having access to global where we have a declared. So this is what we'll call it as a closure. A function, if a function returned from another function, the returned function will still remember its lexical parent state even after the parent function state is removed from call stack. That is what we'll call it as a closure. Okay, now we'll do the complete execution, and we'll see we should still able to get inside child, we still are getting this thing. Now we'll try to understand the closure with respect to let and const. We'll go back to our code, and along with this b, let's create something called c. Okay, c already there. Okay, c d I will be putting 40. Okay, so that I'm declaring in d, and I'm going to declare e in const with value 50. Okay, now what I'm going to do inside this, I'm going to access I'm going to access D as well as E. You can see this D is declared using let, and E is declared using E. Why are we specially seeing let and const? Because this has a different meaning than declaring variable using var, because this is used for block scope declaration of variable. Now we'll try to understand what is happening with respect to let and const in closure. We'll just go to our browser and we'll try to read. Yeah, you can see even if the variable is declared using let or const, that will be still fulfill the closure. Okay, so that will also behave like var keyword declaration. Even the variable declared using let and const will fall under closure. So that will work similar as that var declaration only. There is no difference in that. Now we'll see what will happen if values changes. Maybe if I do something like if I'm just reassigning value b to 100 here in this line. So now I am having value 20 here, and then I'm reassigning this to 100, then I'm returning. Now what should be the value when I console log it here? Because the variable declaration or variable is changed, right? Here the variable is changed before it's getting called. So now we should see the value 100 only in the position of b. Now you see the value 100 only is coming. That is because it is not pointing to the value, it is just pointing to the reference, the variable reference only. So even if this value is changed outside, even just before calling this function, that the changed value only will reflect, because it is not pointing to the value, it is pointing to the variable reference. So that is the one part. And another part is, no matter how many levels we are using, for example, instead of returning this child function inside this, if I call another function called if I return another function called maybe grand child, and inside that if I return a function grandchild, if I return this, so maybe I have to store it again using grand. If I call this guy, I will still have access to this. So no matter how many levels of nesting we have inside function, that will still, the closure will still work in the same way. You can see if I put breakpoint here, it will have one more level of closure. You can see. So you can see closure, I think nothing is there in that child, that is why it is not creating closure. If I declare maybe f equal to 60, now it will have its own closure created. Inside get grandchild, you can see the closure is there for three variables are there, right? So 100, now f is there inside the child closure. You can see if you go inside, there are grand inside that scopes closure. You can see, okay, f is not coming, that is because it is not used. Yeah, that is also one more point. The Chrome browser is smart enough to remove the variable from closure if it is not used. You can see we have f is declared inside child function, that is the parent function for this grandchild, but it is the f is not coming in our closure. That is because f is not used anywhere in the inside this grandchild, right? So to avoid the storage issue, if you are just keeping this f inside storage also, because these variables will be in somehow, it has to take memory, right? Because if this variable is not used anywhere inside this function, so there is no point in keeping this, right? So the browser is smart enough to store only the variables which are used. So now what I'm going to do, I'm going to put f also inside this. No, so now this f is used inside this grandchild scope, so that should be included in the closure. Now if I go and see, where is that? Yeah, you can see there is another closure created called child. This will have access to f. Correct. Yeah. Now we'll try to understand the benefits of using closure. We'll mostly use closure to perform data hiding, or the data can be secured using closure. For example, this parent function is having this much of variable, right? And these variables are having access to its child function using closure. But These variables cannot be changed from outside. Once after this is removed from call stack, they cannot be changed from outside. So maybe I'll just simplify this to demonstrate that. I will just uh, do simple thing. Yeah, inside child, and I'm going to do only this A and B. Okay, I don't have anything. I have A in global context and B inside a parent scope. I'm going to do this call. Okay, so that is all. Okay, now I'll be getting, we'll do this clear. Yeah, inside child, I'm having access to A and B. Now if somebody before calling this function, if they try to change the value of B to 100, this won't affect, this will not change the value of this B which is already in a closure of this child. So this data is protected and it is only read inside this function. You can see we did change value, this is executed, this line is executed. You can see this is executed. If I move to next line, this is executed, but instead of changing its value of closure, it created a new variable called B inside a function, correct? This is not changing this closure, correct? So it provide data security. And another benefit is what it will improve the reusability of function. For example, if we have a function and maybe it is taking count. Okay, so it is having function. Yeah, the one more part I can cover. It's not only the declared variable, whatever parameter the parent function is taking, that is also will be included in the scope. If it is a closure, it will be included in the closure if it is used. For example, I'm just putting what I'll just putting inside this count. I'm putting once this function is called, what I'm going to do, I'm going to do this count minus minus. Okay, so now I'm going to call this. Okay, so when every time when I call this function, it will just inside child, the count number will be printed and it will be removed. Okay, so I will just name it as child 1 and I will pass 3. Okay, then I will pass it with 3 again with child 2. Okay, so this will create unique isolated closure. When we create this instance of function, this will create a closure with this value, this 3, and when I create child 2 instance, it will create a new closure with this value. To prove that, if I call this child 1 function, okay, one time, and maybe I am calling child 1 function 2 time, then I'm calling child 2 function, sorry, calling child 1 function 2 time and calling child 2 function 1 time. What is happening, we'll see. To differentiate, how will differentiate whether it is called from, okay, that is fine, we can see. The first two calls are from child 1 instance, right? So we can see. If I refresh, you can say these first two calls are from child 1 instance, correct? So when I do these two calls, the variable first when we initialize it was 3, so we got this count as 3, then we did a decrement, so the value is updated to 3. But when I call the function using this child 2 instance, again the count is 3. So it proves that it is having isolated closure for each instance of function. So the child 1 instance will have its own isolated closure and child 2 will have its own isolated closure, which will make the function to more reusable. So we can take whatever difference as an argument and we can make this function more reusable. That is all I have for this video. If you are not clear about any of the terminology used in this video, like scope, lexical scope, block scope, call stack, or a global context, whatever, please do let me know in the comment. I will make separate video for that. Thank you for watching.